Hello info person, this is Anton, and today we're going to be discussing some really strange discoveries about asteroids in the solar system. And that's because for a very long time, if you asked an astronomer to basically define an asteroid or explain what one might look like, they would probably describe a kind of a simple lumpy potato floating in the void of outer space. In a sense, a really large rock, possibly covered in a lot of different craters, because of billions of years of interaction with everything else around it. And so for a very long time, astronomers thought of them as these somewhat boring leftovers from the formation of the solar system. But as our telescopes improved, and more importantly, as we started to visit these objects, and as we started to take actual physical pictures of them, that picture changed completely, because now we've discovered worlds that seem to be very unique, very unusual, and nothing like we imagined them to be. For example, there seem to be asteroids that are practically made out of metal, there are asteroids that have their own ring systems, and a lot of them even seem to resemble this: very unusual fluffy piles of rubble that's basically held together by very weak electrostatic forces and just a little bit of gravity. But today we're going to discuss this very recent discovery of what seems to be one of the strangest shapes discovered so far. The asteroid that we've known about for a very long time, but that has finally revealed itself in some of the new images. The asteroid 44 Nysa. The asteroid whose orbit you see right here, and that, like so many other asteroids, finds itself inside the asteroid belt. And though it was not particularly mysterious or unusual before, these recent high-resolution images essentially uncover a shape that looks less like a potato and more like some kind of a ginger root or something. Except that in this case, this is a really massive object. And so this discovery challenges everything we thought we knew about these bodies and how they seem to form. And so let's talk about these discoveries in a bit more detail, but I guess first, let's start with a kind of a gallery of these space oddballs that were discovered previously. Or I guess let's first discuss what scientists have already observed and what scientists understood a new normal asteroid should be like. And well, it turns out that quite a lot of asteroids out there seem to be very similar to Bennu and Ryugu. Specifically, they are basically rubble piles. A collection of much smaller rocks stuck together and held together by very weak microgravity. But importantly, based on a lot of discoveries from larger asteroids, we now know that many of them seem to have formed in a somewhat unusual way by merging with very similar nearby objects. And here's one good example: 216 Cleopatra. This is very often referred to as the dog bone asteroid for the obvious reasons. And basically here it has these two very thick ends connected by a narrow bridge, with scientists now believing that this formed when there was first some kind of a collision with a much larger object that then started to spin really fast and fell apart. But eventually a lot of this spinning debris fused back together and formed this somewhat bizarre shape, with this asteroid even containing two separate moons that seem to represent some of these leftovers. Then we have the observations from the Japanese Hayabusa 1 mission. This is 25143 Itokawa, which basically resembles a kind of a peanut. And though the shape itself is also kind of difficult to explain, what makes this asteroid even more unique are these very unusual smooth areas, or these dust ponds, that seem to contain fine regolith nestled between rugged, boulder-filled terrain. And so here this seems to be a phenomenon where in some asteroids, pockets of dust accumulate over time in various depressions on the surface. And so this kind of does resemble a pond or a lake, but instead of water, it basically contains dust. And though exactly how this is formed and why this is formed is not clear, it's definitely something that seems to occur on quite a lot of different objects. But because many of these asteroids are basically once again rubble piles, quite a lot of them, such as Ryugu, also start to acquire these somewhat strange shapes because of these centrifugal forces that basically pull the material along the equator as the object spins around. And you can sort of see this as this very unusual ridge forming on the equator. And so Bennu and Ryugu, they both kind of look like this because they're essentially both kind of like these huge spinning dust balls. And we know they're dust balls because when NASA's OSIRIS-REx spacecraft tried to touch down on the surface, it literally sank into the asteroid in the same way you sink into a ball pit in some kind of a kid's playground. And so for these rubble asteroids that spin very fast, many of them seem to acquire this somewhat strange shape. And on top of all of this, researchers have also discovered quite a few of these. A lot of asteroids seem to resemble snowmen. Now, Arakoth in the Kuiper Belt is probably the most famous one because this was the first such discovery, but here many asteroids basically end up being fused at the neck because initially they start as a kind of a contact binary, meaning that there are two separate objects that gently bump each other over millions of years of orbit, and eventually they join together, forming a single object. And, well, based on a lot of research, we now know that this is most likely caused by the sun, and specifically the emissions from the sun that first make the asteroid spin really fast and cause it to fall apart, which then forms separate pieces, and which then, over time, come close together and rejoin into a single object once again. With this possibly even happening multiple times over billions and billions of years, resulting in some truly unique shapes, which basically is a perfect transition for this new discovery from 44 Nysa. A special kind of asteroid referred to as an E-type asteroid, which are actually pretty rare and incredibly bright. Nysa actually has the albedo or reflectivity of 0.55, making it reflect more than half the light that hits the surface. And these types of asteroids seem to be made out of enstatite-rich material, which scientists believed might be the same stuff that eventually formed terrestrial planets, including planet Earth, which of course means that these particular asteroids are exceptionally interesting for astronomical studies. But for many decades, Nysa was a bit of a puzzle, mostly because the initial observations were not that clear, and early models suggested that this was just some kind of an elongated and skinny object, similar to asteroid Cleopatra I showed you previously. But for many years, this asteroid managed to avoid a clear identification and observation that to some extent fits its name perfectly. And that's because Nysa, in Greek mythology, is a mythical land of illusion where Dionysus was initially raised. But this didn't stop a team led by Kit Minker at Lowell Observatory to finally try to uncover its shape by using adaptive optics, and specifically optics on the Large Binocular Telescope and the Very Large Telescope, known for their extreme precision, which is essentially what was done in this recent study you can find in the description. And so here, by basically cancelling out the atmospheric effects when observing this object from planet Earth, it allowed them to see surface features from millions of kilometers away. And, well, they found something super strange. Not a contact binary, but something that resembles some kind of a contact trinary or something even more complex. Basically, instead of having two lobes like Cleopatra and Arakoth, Nysa seems to contain multiple lobes, and at least three very distinct lobes, that are joined together by two narrow necks. Technically, these are known as coli. And that's why it basically resembles some kind of a ginger root and not a potato or a dog bone, which makes this the first official example of a contact trinary, or at least an asteroid with a very strange and very complex shape. A shape that would be somewhat challenging to explain. But the surprises did not end there, because in some of the leftover data from these images, the team spotted a faint tiny point of light moving with Nysa as well, which scientists have now identified as a small moon approximately 1 kilometer in size. This is at a distance of about 170 kilometers, which makes Nysa a very strange binary system with one of the most irregular and most difficult to explain shapes of all known asteroids. And though in some sense it could be easily explained if this was a smaller object, here we're talking about an object that's at least 75 kilometers in diameter. So this is actually a pretty large asteroid. But why exactly does this matter, and why would this be important? Well, the thing is, like I said, this sort of challenges the asteroid formation models that did explain everything we've seen so far, and all of the other unusual shapes I've mentioned previously. And in that model, usually, we expect some kind of a multi-body system involving more than two asteroids to either stay separate forever or to collapse into a more spherical shape over time. Yet here we have a shape that's multipolar and potentially stay this way for a very long time. Which of course raises the question of, okay, so what happened here and why does it look this way? Well, right now there are possibly three explanations. First, the hit-and-run theory. It's possible that Nysa is the result of some kind of a hit-and-run collision, where a very large protoplanet was basically grazed by another object, with the tidal stress stripping the mantle of this object into a kind of a string of different objects that was somewhat similar in size, and all of these objects then slowly reaccumulated, forming this three-lobed structure. Which means that if this is correct, there should be very similar objects somewhere nearby, and we should be able to find them at some point. Then maybe this is a result of some kind of a contact trinary. So basically, instead of being two objects, Nysa might have been three separate bodies that very slowly drifted together and, over time, very slowly merged into a single piece. So kind of like Arakoth, but three pieces instead of two. Here though, it would be kind of difficult to explain where these three pieces came from and how they ended up so close. Lastly, Nysa might have started as one solid object that over time was bombarded by many different asteroids, which resulted in catastrophic collapse and basically left a lot of these deep valleys, or these indentations, all over the surface. And though this might explain the overall shape, it doesn't explain one thing. It doesn't explain the two valleys that seem to encircle the entire object. And the fact that all three lobes in this case have the same color and composition suggests that they all came from the same parent body. And so we basically have these three separate explanations, but neither one of them right now is fully accepted. But we do know certain things for sure. For example, we know that all three lobes have the same color and composition, implying that they all came from the same parent body. And if Nysa is a stable contact trinary, it means that all three pieces also came from the same parent body initially. At the same time, this also helps us understand the very important Nysa-Polana complex, a massive family of asteroids in the main belt that represents the largest cluster of asteroids known to us. And while the thing is, even asteroids Bennu and Ryugu seem to also belong to this class, essentially implying that all of them came from the same parent body initially. But there's actually another reason why this is super important, and we recently discussed this in one of the videos about asteroid Eulalia. All three asteroids, Nysa, Polana, and Eulalia, are actually part of the same larger complex, and in this case, they seem to have these overlapping families, all of which seem to have formed approximately 800 million years ago. And based on some of the recent studies, researchers discovered that a lot of these asteroids, when they were formed, dramatically increased collisions in the solar system, which basically bombarded Venus, Mars, and Earth, with signs of these collisions visible everywhere. And for our own planet, we also experienced some major changes on the surface, including the snowball Earth effects, when the entire planet was covered in ice, and the formation of complex life. Now, as I mentioned in that previous video, right now this is just a correlation, not causation, but based on some of these studies, there is an implication that many of these asteroids and the collisions with these asteroids possibly helped some of the complex life to start on Earth. Although when it comes to asteroid Nysa, at the moment it's not entirely certain when it was formed, it just seems to belong to one of these families of asteroids. And so technically, for all we know, it might have formed much earlier and from some other collision. But in the end, this asteroid and a lot of recent discoveries of other asteroids reminds us that we are basically living through the astronomical age of discovery, especially for our own solar system. In just the last few years, researchers discovered so many different things we never knew before, and some of these things were a little bit mysterious and very surprising, with this one obviously being the new mystery. And though at the moment it's difficult to explain why this asteroid acquired the shape, and obviously what's happening on its surface, because of these discoveries, chances are we're going to be discussing this asteroid even more, especially once researchers are able to observe this with some other telescopes like the James Webb. And so here this is not just some kind of a weirdly shaped rock, this is a physical laboratory for studying the building blocks of planets and trying to understand the history of planet Earth. But because we now also found the moon around this object, by studying its motion around Nysa, with time it will be possible to determine its exact mass and thus determine its exact density. And this will tell us for sure what exactly it's made out of, and if this is a solid rock, a piece of metal, or a porous pile of rubble like Ryugu and Bennu. But when it comes to asteroids, the next exciting discovery is going to be coming in the next few months from the Chinese Tianwen-2 mission that's going to be visiting another asteroid, 311P Pan-STARRS, another oddball that sometimes acts like a comet and actually produces 6 cometary tails simply because it's spinning so fast that it's literally throwing itself apart. And we'll be discussing this once Snowmen 2 collects some data and some pictures and sends them back to Earth. And so until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining channel membership that grants you early access. You can also support the channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.